All right, now that we've got a handle on oxidation numbers, we want to come back to why are they useful? Remember that the goal of oxidation numbers is to tell where the electrons are and how they're being transferred. So now we're going to apply this to a balanced chemical equation to tell, is this reaction a reduction oxidation reaction? Is there even a transfer of electrons? And if so, which species is being oxidized? That is, which species is losing electrons? And which species is being reduced? Which element in the chemical equation is gaining the electrons? So to answer these questions, we're going to assign oxidation numbers to all the elements on the reactant side and the product side, and then compare those. So if there's no change in any of the oxidation numbers, then it's not a redox reaction. And we can also see if the oxidation numbers are changing, are they increasing or decreasing? So our first example here is pretty simple. We've got two elements, sodium and chlorine. So on the reactant side, we have sodium and chlorine, and on the product side, we have sodium and chlorine. And I like to write those elements right under the compounds that they're in. Now, notice that on the reactant side, both the sodium and the chlorine are pure elements. So those are by default going to have oxidation states of 0 both. Sodium is elemental, chlorine is also elemental. But once we get over here to the product side, we have NaCl, that's an ionic compound. So the elements are going to have the oxidation states corresponding to their charges. And in a compound, sodium has a +1 oxidation state, and chlorine has a -1 oxidation state. So to summarize what's happening in this oxidation, sodium is going from 0 to +1. Its oxidation number is increasing. That is to say, it's being oxidized. So we say sodium is being oxidized, and chlorine is going from a 0 to a -1 oxidation state. That's a decrease, so we say that chlorine is being reduced. Now, if you remember from first year chemistry that when elements form an ionic compound, the metal loses electrons and the nonmetal gains electrons, and that's where we get the positive and negative charges. So sodium is giving up an electron to the chlorine. Sodium is being oxidized. Oxidation is losing electrons. Where the chlorine is gaining electrons, it's gaining the negative charge, and that's why it's being reduced. Now in our second example, we've got a few more different elements here. So in our first compound, we have sodium, oxygen, and hydrogen. Then we have more hydrogen, sulfur, and oxygen. And on the product side, we have hydrogen and oxygen, then sodium, sulfur, and oxygen. And it's a good idea to examine each element independently in every single compound where you see it come up. Now, sodium hydroxide is an ionic compound. Sodium has a charge of +1. Oxygen and hydrogen follow the rules. Oxygen is -2. Hydrogen bonded to oxygen, which is a nonmetal, gives us +1. And in H2SO4, hydrogen is +1. Those are all nonmetals. Oxygen is -2. And that leaves us with sulfur, which if you want to set it up, we see we have 2 hydrogens, each with an oxidation state of 1, plus the sulfur, plus 4 oxygens, each with a -2, total charge of 0. And if you do out the math, we see that sulfur needs an oxidation state of +6. So there's our reactant side. Now looking at the products, H2O follows all the rules. Hydrogen with a nonmetal is +1, oxygen is -2. Now we have also sodium sulfate, ionic compound, sodium is +1, oxygen is -2. And if we set up the math again for the sulfur, 2 sodiums, each sodium is +1, sulfur plus 4 oxygens, oxygen is -2, total charge of 0. You can see that's exactly the same setup as before, and sulfur is again going to have a +6. Now we can see that none of these oxidation states have changed at all. Every element has the same oxidation state before and after, so we conclude that this is not a redox reaction. And if you notice, in fact, this is an acid-base neutralization reaction between a strong base and a strong acid. And in general, neutralization reactions and precipitation reactions are never going to be redox reactions.